will be working on the second physics practice problem. So we'll start off with reading the problem and underlining important parts. So here we can see that our problem is that a 12.0 kilogram block is uh, is placed on a ramp inclined at 30 degrees to the horizontal. So let me underline this part. This is important, and it's placed on a ramp inclined at 30 degrees to the horizontal. We'll be needing that later. If the block remains at rest, calculate the static frictional force acting on this block. So to start this problem, we will draw our ramp, which will be denoted as a triangle in this case. We need to make sure we draw the angle here. Here it is given to us as 30 degrees. Okay. We need to label our coordinate plane. So this would be positive x here, plus x over right here. And this would be minus x right there. Okay. So here the triangle represents the ramp. We will have to draw a block here, which will be denoted by a dot. So there we go. There we go. So that is our block. So our FBD, now we'll start our forces, drawing our forces. So our first force in this case will be static friction, which always, as we know from our website, on the learn section, we always know that this force will oppose the block's motion, and it is denoted by F of S. So we start from the block, we will draw a line this way. Make sure to label it as F of S. So right here, this will be F of underscore S to show the subscript of S. Next, we will draw our force of gravity, which is right here. And our force of gravity, we always have to remember, as shown on our website, it is always straight down. So in this case, it would not be perpendicular, but would rather be straight down. And then now we just label it. F subscript G. Okay. Next is our normal force, and our normal force, however, is perpendicular to the surface. So our normal force would be going this way. Wait a sec. Our normal force is my bad. Sorry, it's perpendicular, so it'd be this way. And now we label it F subscript N. Okay, and now we have drawn a free body diagram. Now to calculate our problem. So our problem here is asking us for calculating the static frictional force acting on the block. So to start solving this problem, we will start with step 1. Step 1 here will be to break down the force of gravity into two components. So here, this is not part of our free body diagram, but I'll still show it. This will be our perpendicular, our perpendicular side, and this will be another side will be our parallel component, or in other words, the horizontal component. So that will be just two components to it, but we will not be drawing there, just to illustrate. I showed it to you. So now we start with our formula. So that will be the force of gravity. Let me write this down. So F of, let me, that will be smaller. Okay, so F of G, which is in this case, which is force of gravity. F of G sine of theta is equal to the force of static friction. So the static frictional force, which is F of S. And the reason I said it equal to the static frictional force is because, as stated in the problem, the object or the block remains at rest. So therefore, the net force here is equal to 0, and both forces have to equal each other. So now we know that theta is 30 degrees, as shown here. We know that theta equals 30. So we now have to solve for f of g using an equation. So the equation which we will move to solve for f of g is force equals mass and acceleration. So f of net is equal to m times a. So as we can recall from our problem, mass is 12 kilograms. So we just simply plug in our values that we are given. So 12.0 kilograms times the acceleration. And for acceleration, we would be using the horizontal or the parallel component that I drew. So that would mean that we're the force of gravity. We're just using the force of gravity as our acceleration, and in this case, we would just be approximately using it as 10. So it would just be 10. So it would be times 10 meters slash second squared. And this is equal to f of net. So f of g, you can say. So here it will be f sub g is equal to this. Sorry if it's a little bit out of order. And this would give us the value f of g is equal to what? If you do a simple calculation, this gives us f subscript g is equal to 120 newtons. Now that we know that f of g is equal to 120 newtons, we simply plug it in back to our original equation. So this would be, I'll just move it over here. Just put an arrow real quick showing our work going this way. Okay, and here you can simply plug it in. So show 120 newtons times sine of 30 degrees, as we mentioned before, our angle given is 30 degrees. I can't draw the degree symbol here, so I'll just say it out loud. 30 degrees. And if you do a simple calculation and plug it in, let me plug into my scientific calculator. This would result in f subscript s to this. Now f subscript s is equal to, and if you plug it in, is equal to 60 newtons. And that is our final answer. Let's check back with the question. It says calculate a 12 kilogram block is placed on a ramp inclined at 30 degrees to the horizontal. We use 30 degrees, we use 12 kilograms. If the block remains at rest, so we put them equal to each other, calculate the static frictional force, or F of S, acting on the object, and we calculate it here. So just all we have to do is bold the answer and we will be done. Okay, thank you for watching, and I'll see you in the next video.